All right, so we're going to solve this equation, x squared minus 2x minus 3 less than or equal to 0. Here are instructions that we wrote on the top of page 341. So if you weren't here, you might want to pause the video to write down those first three. And then I'll move it down so you can see number 4. Okay, I'll move it back up so you can pause it. All right, here we go. So we have this, and we start by imagining this is just like a quadratic equation. We already have one side equal to 0, so step 1 was already done. If this was an equals sign, we'd probably say, well, if I wanted to solve this, the fastest way is factoring if I could factor it. So if I just made it equal to 0 temporarily, and I factored it, x and x, 3 and 1, I'm going to need a negative 3 and a plus 1. I get solutions of x equals 3 and x equals negative 1. Those are my x-intercepts on a graph. Now, if we think of our number line, if we think of our x-axis, and we think here's negative 1 and here is 3, 0, 1, 2, okay, not quite spaced out perfectly, but good enough. If we think of that as our number line, our x-intercepts happen right here at negative 1 and right here at 3. Now, one of the notes that we made was if it's a less than or equal sign, those points will be included, so we would show these as closed, not open circles. So I'll color them in. Now for step 3, it says you could use the graph or the test points. If I was using the graph, I would think if I graphed y equals x squared minus 2x minus 3, and I knew those were the x-intercepts, would my graph open up or would it open down? It would open up. Why? Because the x squared, the number in front of x squared, is positive. So if we just imagine the parabola, it would look like this. Imagining that parabola looking like this, and we're trying to find out where it's less than or equal to 0, can you see that this section is the true section because it's less than or equal to 0? Yeah. And these sections are false because in these sections it's bigger than or equal to 0 because your graph is above. Now the way that the test points work, if you were going to use that as a strategy, is you would choose a point in each of the sections. Section 1 is before negative 1. Section 2 is between negative 1 and 3. And section 3 is above 3 in this case. So if you pick a number less than negative 1, negative 2, and you plug in negative 2, you would get 4 plus 4 minus 3, which is 5. Is 5 less than or equal to 0? No. So you would write false. That's using a test point. And you would know since one point in this section is false, all the points in that section will be false. What's a point between negative 1 and 3? Probably the easiest one to use would be 0. Plug in 0 and you get negative 3. Is negative 3 less than or equal to 0? True. So you know that this entire section will be true. What about something larger than 3? Like 4 or 5. And it doesn't matter what value you choose. So if we choose 5, 25 minus 10 minus 3 is 12. That is not less than or equal to 0. So we know that it's false. And so our only solution is here between negative 1 and 3. So then we write our solution. In set notation, you would say it's between negative 1 and 3, and all real numbers would work. In interval notation, you would write this smallest value is negative 1, the biggest value is 3, and you would use square brackets to show that negative 1 and 3 are included. Now this sets us up, especially writing the true and false, really sets you up for curve sketching later on once you take calculus. Because once you take calculus, you do a very similar sign diagram. So this is really the basis for that moving forward. But I find a lot of people with parabolas find that if they draw the parabola just in dotted line like we did there, you see how easy it was to see that this section was false, this section was true, and that section was false? So often the graph is a quicker way to figure it out rather than doing 3 test points.